Good morning. This is the last video for AP Calc section 3.4. Today we are talking about the second derivative test, which is another way to find a max or a min for a function. All right, let's not forget the first derivative test. And what confuses people normally about this lesson is really we're just giving another way to find maxes and mins. But you already know how to find maxes and mins using the first derivative test. You take the first derivative, you find where the first derivative equals 0 or is undefined. Those are your critical numbers. And then you make your table of values with your intervals, and you find intervals that are increasing and decreasing. And if the function changes from increasing to decreasing at a point, then there is a max or vice versa. That still works perfectly. But there's a second way we can find maximums, which sometimes is easier, which is why I want to show it to you. Okay, so now we're talking about how I can use the second derivative to find maxes or mins. So the second derivative test says this: second derivative test can also be used to find our max or mins. And then recall that we've already used the second derivative by finding where it's 0 undefined and making intervals, and that told us concave up and down intervals. But here's a second derivative test, and let's make sure we're reading this carefully. It says if f prime of c equals 0, f prime, that's the first derivative. So if the first derivative of a point equals 0 and the second derivative exists, then we have two conclusions. If the second derivative is positive, there's a relative min. And if the second derivative is negative, there's relative max. So let me graphically, visually make sense of that. All right. So here's a function, and I have just a parabola, and I have a point C there, and clearly my picture's getting in the way here. Clearly the first derivative is 0 at C, which just means there's a horizontal tangent. So there's my horizontal tangent. And it turns out if I take the second derivative and I evaluate the second derivative at point C, it turns out to be 0. Now, you need to know what that means. If I find the value of the second derivative of a point and it's positive, you now know that means it's concave up. So think about it. If the first derivative is 0, so the horizontal tangent, and the curve is concave up, then that point, in fact, I wrote this backwards. Sorry, there's a typo there, certainly. That should be min. Then there is a min. Sorry, I'm writing with my mouse here. Then there's a min at x equals c. So if the first derivative is 0 and the second derivative is positive, then there's a min. And I could do one upside down too. If the first derivative is 0 and the second derivative is negative, so it's concave down, then there's a max. Notice that what I don't need for this process is I don't need to know where the second derivative equals 0. So if the goal is just to use the second derivative test to find maxes or mins, I don't need to find where the second derivative equals 0 and then make intervals and find all my concave up and down intervals. I just need to evaluate the critical number, which is a first derivative number, in the second derivative. So that's the difference. Okay. All right. I've got one example here. And it says, use the second derivative test to find any max or mins for f of x equals negative 3x to the fifth plus 5x cubed. So first I took the first derivative, fairly easy derivative, negative 15x to the third plus 15x squared. And again, my note here, we could use the first derivative test. And if the problem just says find maxes or mins, there's nothing wrong with using the process that you already know. Use the first derivative test. We can set this equal to 0, find critical numbers, make our first derivative table, find intervals of increasing and decreasing. And then if it changes from increasing to decreasing, there's a max. Like that will still work. What you'll find here is, because the question then becomes, which method should I use to find max or mins? And this note here tries to answer that question. It says we could use the first derivative test to find the max and the min. If the second derivative is easy to find, like if it's an easy derivative to take, the second derivative, then this second derivative test might be an easier way to find maxes and mins. If the second derivative is an ugly quotient rule, chain rule, natural log, then you're probably for sure better off using your first derivative, making your table, increasing, decreasing. And a lot of students still always like to use that method because they learned it first. But this method really can be helpful. So we found the first derivative. Remember, we still need the critical numbers. We have to find where the first derivative equals 0 to find where there might be maxes or mins. So here I took the first derivative and I factored it out here underneath here, factored out a negative 15x squared. And I ended up with three critical numbers, x equals 0, x equals 1, x equals negative 1. And again, I could make my first derivative table and go that way, but this question said to use the second derivative test. And I think this is a good example of when it's helpful to use the second derivative test, because the second derivative is easy to take. There's my first derivative, negative 15x to the fourth plus 15x squared. To take the derivative of excuse me, to take the derivative of that is not difficult. So my second derivative, here it is. It is negative 60x cubed plus 30x. And I factored out a negative 30x. I get 2x squared minus 1. There's my second derivative. Again, I do not need to know where that second derivative equals 0 or is undefined. That would tell me where the concavity changes, which the question could ask. This one doesn't want that. It wants max or min. So you need to know we're now going to evaluate the three critical numbers in that second derivative. And if they're positive, means concave up, there'd be a min at that point. If it's negative, concave down, there's a max. If it equals 0, then the second derivative test just doesn't tell us anything. Then we probably would need to use the first derivative test. So I plugged in, evaluated the three critical numbers. First is negative 1. Here's f double prime of negative 1. Turned out to be positive, which means at negative 1, the first derivative is 0, horizontal tangent, and the function is concave up. Oh, again, I've got the wrong conclusion. I apologize for that. It is concave up when you look at. So I completely, very much apologize for that. It is concave up at x equals negative 1. So if the first derivative is 0 and it's concave up, there is, in fact, a min at x equals negative 1. Okay. The next critical number was 0. My lights are turned off. I've learned to care less. Okay. The second one, you'll notice the second derivative is 0. That means it's neither concave up or concave down. You have to understand it doesn't prove anything. That just means the second derivative test does not tell us whether there's a max or min. We, in that case, would have to use the first derivative test. So that one didn't help us much there. And then the third one is f double prime of 1. And again, I evaluate that. The second derivative turns out to be negative. That means at x equals 1, the first derivative is 0, horizontal tangent, and the second derivative is negative. Again, same mistake here, sorry. Second derivative is negative, which means it's concave down, which means there's a max at x equals 1. So it's just another way to find maxes or mins. Doesn't mean it has to be, you have to do it this way. There's nothing wrong with making your first derivative table. But you've got to know just the conclusion that are typed here. You have to understand that if the first derivative is 0 at a point and the second derivative is positive, you have to understand that that means there's a min. First derivative is 0, concave up. So it's just that process. And this last assignment just has you using the second derivative test to find max or mins. There's your assignment. It's all of 27. I think it's eight odd problems where you're using the second derivative test to find maxes or mins. Okay, that's all I've got. We have one last section in chapter 3, which will start on Tuesday and then do a live lesson on Wednesday and then kind of be done from there. So that's it. Have a great Monday.